Good afternoon, students. Am I audible for all of you?
Good afternoon, sir.
Okay, and just wait few minutes for rest of the students. Then we will continue the session. Okay. So in the last class, we have started discussion about the SIF register. Uh, just SIF register. I'm audible for all of you. Yes or no? You are getting my
Yes,
voice. Okay. So
yes,
actually, actually, we know that one flip-flop can store one bit of information, and in order to store the multiple bit of information, we require the multiple flip-flop. So, with the help of multiple flip-flop, we can store the multiple bit of information. Okay. Now, the thing is that that the group of flip-flops that is uh, used to store the binary data that is known as the register. And in the earlier class, we already discussed that mainly there are four shift register, that is serial in, serial out shift register, serial in, parallel out shift register, parallel in, serial out shift register, and parallel in, parallel out shift register. So these are the four shift register. And in the last class, we already discussed about the serial in and serial out, that is called in short CISO shift register. So today we will discuss the rest of the three, that is the serial in, parallel out, and parallel in, serial out. There is some network issue. That's why mm, the class was disconnected. Just 1 minute. So here actually I am drawing the serial in serial out shift register that is called the CISO shift register. Okay. So for this I am drawing here. So this is the serial input. Here it is we are mentioning D2, and this is Q2. This is like D1. This is Q1, and this is D0, and this is Q0. So this is called the serial output, and this is called serial input. Okay, and this we are D flip-flop, and you already know there is a clock in D flip-flop. So this is the clock. Okay, so actually, this is a block diagram of serial in, serial out shift register. This block diagram of 3-bit CISO shift register. Okay, so here, just yeah, and this is the clock.
वेटिंग में अभिजीत सर
Due to network issue, again and again the class is disconnected. I'm trying to demonstrate again. This is D2, this is Q2, this is D1, this is Q1, and this is D0, and this is Q0. Okay, and here mainly this is the clock. Okay, so this is the here, this is the serial input, and this is the output. One thing. Okay, so here you can see this block diagram consists of the 3D flip-flop. These are the 3D flip-flop, and this is cascade. This is cascade, and this is connected with each other. Okay, one thing, and here cascade means also that the output of one D flip-flop is connected as the input of the next D flip-flop. Okay, and all these flip-flops are synchronized with each other, and the same clock signal is applied to each one. So this is the clock. This is the clock. So here one thing that is that in this shift register we can send this bit serially from the input of the left most D flip-flop, and that's why the input is called the serial input. Here it is only mentioned the input, and for every positive edge triggering of clock signal, the data shifts from one stage to the next. So we can receive the bits serially from the output of the rightmost D flip-flop. Okay, so that's why the output is called the serial output. So here this is the Q0. So Q0 is the serial output, and here D2 is the serial input. Now for our example, so let us see the working of 3-bit CISO shift register. So for this, we are sending the binary information, that is 0, 1, 1. So from LSB to MSB, this is the LSB and this is the MSB. And at this moment, we are assuming the initial status of the D flip-flop of from the left to right most, that is Q2, Q1, and Q0, all are 0. So initial condition Q2, Q1, and Q0 all have value that is 0, 0, and 0. So we can understand the working of shift registers. So for this, we are drawing here a table that is, suppose number of positive edge clock input Q2, Q1, and Q0. Okay. Now, first, there is no positive edge. So at this moment, it is 0, 0, 0. Second, it is 1. So LSB here 1. LSB means here Q2. Q2 is 1. This is LSB from here, and this is MSB. So Q2 value is 1, and the next 2 is 0, 0. Next is the number of positive bits is 2. So here again it is 1. 1 means here this is 1. So the value of Q2 now shifted to Q1. So for this case, the Q1 is also 1, and the value of Q0 is 0. Next is 3. Okay, so MSB here, the value of input is 0. Okay, the value of MSB is 0. So in that case, it is 0. Now the Q1 is shifted to Q0 and Q2 is shifted to Q1. So it is 1 and it is 1. So number of 4, so 4, it is 0 and 1, and for the case of 5, it is 0. So from this table, you can see the initial status of the D flip-flop in the absence of clock signal, that is Q2, Q1, and Q0. It is 0, 0, 0. And here the serial input is coming from the Q0. So this is the, sorry, here the serial output. The serial output is coming from the Q0. So the LSB1 is received from the third positive base clock, and the MSB0 is received the fifth positive base clock. So here you can see from this table. Now, therefore, the 3-bit CISO shift register requires the 5 clock pulses in order to produce the valid output. Okay. So similarly, for the n-bit CISO shift register, it is required in the last case we already see 2n minus 1 clock pulse in order to shift the n-bit information. Okay. So this is the concept about the serial in, serial out shift register. Now next we will discuss, that is the parallel in, serial out, serial in, parallel out shift register. Okay, so serial in, parallel out shift register. Just 1 minute. This is the clock. Okay, and here this is the D2, and this is Q2. This is D2. This is D1. This is Q1, and this is D0, Q0. This is output. This is the input. Okay, this is the parallel output, and this is the serial input. Here, this is serial input, and here it is parallel output. So, so this is the serial in parallel out. Serial in parallel out shift register. So here, in short, you can call this the C4 shift register. So this is a block diagram of 3-bit C4 shift register. So here again, the circuit consists of 3 D flip-flop, which is cascade, and here you can see again that the output of one D flip-flop is connected to the input of the next D flip-flop, and all this flip-flop is synchronized, okay, with each other. And here the same clock pulse is applied to each one. Now in this shift register, we can send the data, send the bits serially from the input of the leftmost D flip-flop. So here the input is called the serial input, and here the for positive every positive triggering of clock signal, the data shifted from one stage to the next. Okay, so now so actually in this case we can access the output of the each D flip-flop in parallel. So we will get the parallel output from the shift register. Now again we are taking the example by sending the binary information, that is 0 1 1 from the LSB to MSB serially at the input. Now we are assuming again that Q2, Q1 and Q0 all are 0 0 0. So actually here Q2 is the MSB and Q0 is the LSB. So from the table we can understand the working of 3-bit C4 shift register. So for this here we are writing the number of positive edge of clock. This is serial input. This is Q2, Q1 and Q0. So first is 0. So for this case, it is 0 0 0. First next, the first number 1. So for this, the serial input is 1. In that case, the Q2 is only 1. The rest of the is 0. The number of positive is clock 2. So here the LSB is 1. So here Q1 2 is 1 now, and Q1 is also 1. The rest is 0. And the number 3, this is 0, where it is 0, 1 and 1. So the initial stage of the D flip-flop in the absence of clock signal, that is Q2, Q1 and Q0 equals to 0 0 0, and the binary information, that is here we are considering the 0 1 1. 1 is actually obtained in parallel at the output of the D flip-flop for third positive edge of the clock. 0 1 1. Here you can see this is 0 1 1. Okay, so the 3-bit shift register requires the 3 clock pulse in order to produce the valid output. Okay, so this is the concept about the SHIFO or serial in parallel out shift register, and the last one, that is the parallel in serial out or piezo shift register. So this is the last one. So for this case, so first, okay, so this is D2, Q2, D1, Q1, D0, Q0. So this is okay. Now one thing is that here, this is the concept. Okay, so just wait. This is the parallel input, and this is the present enable, and this is the serial out. Okay, so this shift register is called the parallel in serial out shift register. So here this is the block diagram of 3-bit piezo shift register. Okay, so there actually in this, again in this circuit, the circuit consists of 3 D flip flop, which is again it is cascade, and the output of one D flip flop is connected as the input of next D flip flop. And here the all these flip flops are synchronized with each other, and here you can see this is the clock also. This clock is applied. Now in this shift register, we can apply the parallel input to each D flip flop by marking the present enable to 1. So you already got that the present enable in the topmost position, and for every positive edge triggering of clock signal, the data shift from the one stage to the next, and we will get the serial output from the rightmost D flip flop. So again, we are considering here the binary information, that is 0, 1, 1. So for this 3-bit piezo shift register, by applying the binary information 0, 1, 1 in parallel to the present input. So for this case, the present input are applied before the positive edge of clock, and the initial status of the D flip flop from left to right, that is Q2, Q1, and Q0 equals to 0, 1, 1. Okay, 0, 1, 1. And we can understand here. So for this case, number of positive edge of clock, and this is Q2, Q1, and Q0. So first this is 0. So for this case, Q2 is 0, 1, 1. Second is 1. So in this case, this is 0, 1, and 2. So here this is 0. So here from this table, you can see the serial output is coming from the Q2, and the LSB one is received before applying the positive edge of clock, and the MSB zero is received at the second positive edge of the clock. Okay, so therefore the piso shift register, the 3-bit piso shift register requires two clock pulses in order to produce the valid output. Okay, so and the last case, that is the parallel in parallel out shift register. So just okay. So now the last case, that is the parallel in parallel out. So in that case, only the difference is that, just 1 minute. Okay. So last case for the here only, this is one, and this is again one. So this is parallel. And where okay. So this is the parallel in parallel out, that is PIPO shift register. So here again you are watching that there is this circuit is consist of 3D flip flop, and it is connected uh, with the as the input of the next D flip flop, and all the flip flop is synchronized. Now in this case, the shift register, we can apply the parallel input to each D flip flop by making the present enable 1. So here we can apply the parallel inputs to the present or clear, you can say, and these two are asynchronous input. Earlier cases we have seen the synchronized input, but here we are watching the asynchronous input. So what is the asynchronous means? Asynchronous means the flip-flop produce the corresponding output based on the values of the asynchronous input. So in this case, the effect of the output is independent of clock transition. So we will get the parallel output from each D flip-flop. Now, for this case, again, let us working of 3-bit PIPO shift register by applying the binary information, that is 0, 1, 1 in parallel to the present input. So for this case, again, the Q2, Q1, and Q0 equals to 0, 1, 1. So the binary information, that is 0, 1, 1 actually 011 actually obtained in parallel at the output of D flip flop before applying the positive edge of clock. Okay, so for this case only, the PIPO, or the 3-bit PIPO shift register requires 0 clock pulse in order to produce the valid output. So for the case of a 3-bit PIPO shift register, there is no need of clock pulses to produce the valid output. Okay, so these are the concept about the shift register. Now I am requesting all the participants write your name in the chat box for the attendance. Write your name in the chat box. Jaldi. At this moment, there is 22 students, but I am getting only 16 responses.
Excuse me, sir.
Yeah,
Sir, I have a doubt. Can I ask?
yeah. Tell me.
Sir, as mentioned in the syllabus, there is a term that specification or simplification of SOP and POS.
Yeah.
Sir, what that simply means?
You are lateral student who said?
Yes, sir. Yes, sir.
Uh,
Lateral student, sir.
yeah. Actually, in the earlier class, we already discussed the SOP and POS. Okay. So you just go through the video of the recording classes. If your doubt is not clear, then I will definitely clear your doubt. Okay.
Okay, sir. Thank you.
Okay. Okay, I am again. I already told here 2 times. I will not say again for for giving the attendance in the chat box. Okay, so actually today the class is over. In the next class we will discuss the different topic. I think you all understand today's topic. If there is any doubt, you can ask in the next class. Okay. Thank you. I am ending this session now. Thank you all for participating in this session.
Thank you, sir.
Thank you, sir.